Welcome back to the third part of the unit. So in this video, we'll talk about automation, which is, of course, an important part of IoT applications. And also it is associated with the smart grid because, well, one part of the building is that you need to use electricity, right? But of course, building automation is far beyond the management of electricity. So a building automation system is a computerized intelligent system that controls and measures lighting, climate, security, and other mechanical and electrical systems in a building. Basically, the electricity is just one part of it. The purpose of it is typically reduce as well as increase control, comfort, reliability, ease of use for maintenance. Some examples. Sometimes some of these you may have experience. So control of heating, cooling, and venture based day, outside temperature and occupancy. Yeah. So if no people are in there, it does not need to be warm up that much. Yeah, easy to understand. And another example, automatic control of air handlers, optimize mixture of outside air in ventilation. And also it helps supervisional control and monitoring to maintenance. And further examples include outsourcing the monitoring and operation, more operation center. Yeah, that's what I have in my house. And it also provided a collection for the statistics and also monitor CO and CO2 levels and intrusion and fire detection, glass breaking sensors, right? And building access. Well, that's a very typical level, especially if you live in a big city like New York. So for some apartments, you need to have an RFID card or something before you can. So that all these examples all belong to commercial building automation. So BAS is normally distributed by nature and allow every subsystem to continue operation in case of failure of another. So an ABS composed of following components: so sensors, actuators, PLCs that can handle multiple inputs and outputs in real time and perform regulating functions. A server, as well as some network cables capabilities. So the PLC here, it seems more like you can consider to be a local processor. In that case, basically we're taking the data from the sensor and then upload it to the cloud services, and also it can activate the actuators. So for this illustration, so PLC looks like under the context of commercial building automation, it is like the role of the gateway or the gateway and mediator in the IoT structure and the IoT architecture. So it interfaces with the sensors and actuators and provide communication capabilities using different methods to the high-level applications. In that case, we would like to show a case study consisting of two phases to illustrate how commercial building automation can be done. In phase one, we show what in regard to building automation. In phase two, we show some new opportunities to building automation, such as the smart grid and the Internet of Things. Phase one, commercial building automation today. So in that case, we have company A, the energy efficiency. Basically, we want to reduce energy by 25%, so that they communicate with building automation company B, and they have a 5-step plan, including the collecting data, the collecting analysis, the judgment, connect to a local server, and connect the building to a remote operating center. Basically, that's the typical layout here. The local server and the remote server, and connect the devices using PLC. Okay, let's keep further explain the five plan. Yeah, we'll just skip this part. One of the most central features of the improved system is the new web-based e-report. It provides information about current consumption, and other key parameters of the building. It's to be used to make short-term decisions as well as long-term planning. Everyone have access to the web portal because it is not only important for the maintenance staff, but also needed for create awareness among everyone in the company. So it is accessible to everyone. The next phase of the project consists of systems in the building and analyzing dynamics to be able to perform intelligent control. So it helps to improve performance and reduce maintenance costs. So what we step to completion involves setting up a web-based SCADA. Well, we mentioned these two units before: supervisory control and data acquisition system for remote. And also through the web portal, the users can access information from the building. Basically, it's for data usage. So with this hardware implemented, Company A decided to outsource the operation and daily maintenance of the systems to Company B by utilizing their cloud-based offering. So for Company B, they will monitor the building, and also if there's anything wrong, the supervisors and the maintenance staff of Company A will be notified with SMS or email. And in addition to the notifications, Company B can also assist with an adjustment remotely. So just in case the maintenance personnel of Company A is not available, is already available commonly. For Company A, the most improvement is the energy reduction, and also is the knowledge transfer benefit. Okay, for the technical overview of the current stage. So basically, each building is equipped with a set of meters and sensors to measure kind of things, as well as one or more PLC, programmable logic controllers. Well, for some of you who have taken automation courses of what PLCs are, right? So it's just like this. So we have the devices. So the water, power, temperature, they are all connected to the PLC using different methods. For example, the Z-Wave, the USB, all kinds of things. And with the help of the IP modem and the 3G modem, so the data can be accessed to the operation center. So PLC basically takes care of the sensor data, and then by using the IP modem, the PLC can be connected to the internet. To connect to the internet, we need cables, or in this case, we use the 3G modem. Nowadays, it will be 5G modems. But anyway, basically this modem provides the communication method to the internet. And IP modem here is to ensure that the functionalities of the PLC can be realized by using the IP technologies. So the PLC itself does not provide the IP capabilities. In other words, so the servers cannot locate this PLC using IP directly. In that case, we need to have an IP modem. Just think about your house. So basically, you have a Wi-Fi router, right? And before the Wi-Fi router, you will also have a modem. For the modem, one side of it is connected to the wall. Basically, you have some coaxial wires or cables you need to connect to the wall, right? So that's IP modem. So that you have the IP functionality. So the same also here. But in your house, after you connect it to the hole in the wall, the IP you already internet. But in this case, it's a 3G modem, so they can have the wide area network capabilities. See, as can be seen, the PLC monitoring and control. So they also feature devices in building, feature user interface for configuration, and it is possible to remotely configure the PLCs from the operation center. Basically, sometimes there may be some firmware updates or some kind of things like so that the service center can access the PLC and do all this directly, remotely. the PLC performs real-time monitoring and control of devices. So it communicates with the devices using different protocols. All logic necessary to building is contained within the PLCs. Basically, the PLC is the local brain of the devices. In that case, it also means that the building system can remain fully operational during the period of network outage. So we don't want that if the power is out, then the does not have a brain. So in that case, in the PLC will still follow the logic, basically the programs, to do whatever it's do. When we go to the management part, we have the, well, it's quite long with OPC. Server provides access to data, alarms, and statistics from the PLCs. PC is located, okay, basically it communicates with the PLCs. So when a value is requested from user, a request is sent from the user's OPC client to the OPC server containing the OPC tag. Basically, it finds out, OPC server finds out which PLC it needs to communicate to obtain the data it requires. On the other hand, if later on we will just one of the devices, the OPC will be in charge of communicating the PLC and implementing the control activities. SCADA system is used for operational monitoring of the building and providing information from all the relevant building. It uses OPC protocol, and the maintain operations staff can connect to the web browser to obtain the data. So once again, the SCADA server is the data analytics. Yeah, server, it is straightforward. It looks at all historical readings from the buildings and make it possible aspects. And also, yeah, basically it deals with the data, right? It is possible to gather record readings regardless of the vendor. And typical reports include the trends, cost, budgets, something like that. And the value chain is located here. Basically, it is a straightforward one. So we have the hardware manufacturers, and then we have software developers and vendors, and we have system integrator providers. Yeah, so very typical, right? First we have the hardware, and then we bring the software, and then we integrate hardware software with the building devices, and then the service provides servers, remote monitoring, configuration, those kind of things. Okay, so far we have described what we are able to do now. Actually, many of these are quite common. Some buildings may not have the full implementation. Most functions are now able to be. Okay, now let's look at the phase 2, basically commercial building automation in the future. What we can do further. The two major factors will drive the evolution of building automation. One is the information, and the next one is legislation. So for information, the idea is that because we have many sensors, basically it will provide many data, a lot of data, which we may not be fully used. We may not be fully used at this moment. Access to well-packaged information will provide the basic needs for decisions and behavioral changes. So for example, the electricity prices can change the behavior, right? And also for the registration and the test credit to some degree will provide second driver. Basically, if we can do something following the legislation, following the policies, then we will have more savings, likely. So basically, the cycle, it will be like this. So the connected devices will generate the data. So usually it is big data on the cloud and open data. And also we need registration to make sure the data is used properly. And for the data, we will generate information. For this part, remember we have the data aggregators and also the information marketplace. Basically, the data and information themselves can be products and can be exchanged and can be sold. And for the information, it hopes to change the behavior, and not change, maybe affect behavior. via the energy prices and also the social media and also via the apps and services. After the behavior change, there will be no new demand for information and automation. The devices will be commercialized and something like that. So this will repeat again and again. Promise of scale, and it will be possible to buy advanced devices off the shelf, perform installation, and connect them directly in the future. So let's come back to the example of company A and company B. So a few years have passed and company A has decided to outsource the maintenance of its building to local contractors who provide services to several other customers in the neighborhood. So do you remember this? So company B is actually providing all the services to company A, right? So it's only the relationship between company A and company B. But now company A will outsource one of the function, one of the services, which is the maintenance, to another contractor. Maybe it provides better services, maybe it provides lower prices, who knows? It will save price. In this case, because the utilities are shared caretaker pool. Okay. At the same time, they plan to upgrade their system to become fully automated with, for example, occupation center, automated lighting, and integrated access control. So to do this, they will make use of the existing IP infrastructure, so that they can reduce the maintenance cost. And also a shared infrastructure also needs to increase energy efficiency. New policy incentives in regards to energy efficiency have increased the development pace in the building automation area. So many neighboring buildings in company A are now fitted with building automation. So they will have a sharing of information and resources, and also the increased customer also enable new niches in the value chain. We will look into what these new niches are in the next few slides. So, but for here, we mentioned that previously, as we mentioned, it's only the relationship between company A and company B, right? But now with the information sharing, so that opens up new opportunities with the neighboring buildings. So, for example, the several buildings can work as a group to reach the overall maximum, for example. Another example is that for these buildings, if they want to do maintenance, so the maintenance schedule can be optimized across this instead of just one. When before the rule was to have one single integrator and service provider, we now see a multitude of new actors. So that's the new niches, such as specialized service provider for remote monitoring, security, optimization, data collection, and data analytics. What it mentions here is that, so we don't need company B to do all the things itself. So basically all these services can be separated and be provided by different service providers. So in that case, we have the new niche, the cloud service broker. Basically, a cloud broker is an entity that manages the use, performance, and delivery of cloud services and negotiate relationship between cloud providers and cloud consumers. So basically, for the idea is like for the customers, it needs something, right? For the service provider, they have the service, different service. So we need the broker serving as a medium between them, so that the customer tells the broker what kind of service it needs, and the broker can bring in the corresponding services. And sometimes there may be some competition and some comparison there to satisfy the requirement of the customers. In that case, the customers does not need to interact with the service provider directly, because they, for many reasons, perhaps they don't have that much access to the information, selecting the service providers. But anyway, so with the help of a broker, so the requirements from the customers can be better satisfied. Just think about you go to the stockbroker, talk to a stockbroker, think about his or her job. So that's quite similar to the cloud broker, cloud service broker here. The process of integrating with the maintenance contractor system, new contractor, is simplified the service broker because it provides immediate access to the company's BAS. Yeah, that's another aspect I didn't mention just now. So for the broker, for service broker, it will also have provider access or for information communication. So it provides a bridge that converts between common protocols used for building automation. With that being done, so company A will also follow the standardized protocols. They will use the commission application protocol, and also they will choose a new service provider that can replace old systems for PLC control, SCADA, and something like that. The new platform also provides data brokering, so that gives access to a multitude of data sources such as following. So basically, the brokering is a new area that will come into being. Apart from providing access to the new service providers, the cloud broker also has a client API that enables third-party app developers to create applications. So basically, for the broker, it bridges the information flow between the service provider and the user. So the API is also one part of it. So some of the functions that can be provided in the apps include control the ACE, report problems, integrate with Outlook, to adjust meeting rooms, something like that. Well, within this, in this case, so it need to be, they still stick to the IP technology. We have mentioned the importance of IP many times. So there are several IP-based protocols to select from. In this context, we use COAP and also, well, sensor markup language. So we don't need to go into details for these two protocols. Basically, COAP is dealing with the automatic discovery as well as the semantic description of the services, and the sensor markup language is dealing with the content of the message. Yeah, that's what you need to do. You don't need to go to much detail. Just know that we need to use IP technology here. So this is a updated architecture. So it's very similar to before, but this time we'll use a COAP gateway so that we can better integrate all the devices. And also we may use an VPN or the firewall to improve the security. So VPN, I use this figure here to illustrate previously, so nothing is encrypted, so it may be subject to cyber attacks. But with the VPN client and the VPN server, so maybe the user devices and the VPN client are connected without encryption, but usually this is very short distance, so it's relatively safe, and then the communication here will be encrypted. And yeah, as mentioned, there are still a few legacy devices, and this needs a gateway to enable communication with the IP system. In that case, a local resource directory and data cache is also installed to keep track of all the devices. Once again, normal network firewall and the VPN connection is needed for the communication. For the apps on the cloud here, so basically they deal with several things, including the data storage, the functionality management, and also it has a global resource directory with semantic resources and data description. Basically, it helps to organize the data. So as the demand for machine-to-machine service grows, new niches in value chains will emerge. So such as information brokers, service enablement providers. So they will have new case areas. They will also provide openness and privacy and security is always an issue here. So for the value chain, so remember that in the previous value chain, it is a straightforward value chain without much interaction between different actors. But for the new value chain, for the commercial building automation, so we have the interaction between different actors in the system.